Hello everyone, and thank you for joining me for part 3 of the full stack Apollo GraphQL with React and Node tutorial. And today we're going to start hooking up our data sources. And this will be part 1 of a 2-part subseries. And in this part we'll get our earthquake data from the USGS earthquake catalog. Right. So since we don't really know yet what the response is going to look like, let's go ahead and explore the data we're going to get back from the earthquake catalog a little bit. So for now, if you can go into your project root, create a folder, and we'll just call it Data Explore, and create a new file, call it quakefetch.js. Alright, and we can use the fetch API to help us look at that data. So if you are familiar with the using fetch page at MDN Web Docs, you can just go down and copy this bit of code, put it in our file. Right. We want to see the response exactly as it is, so you don't need to worry about this stringify part. Let's not call it myJSON. Let's call it Quake data. Of course, we're not using this URL right here. Actually, in this case, we're going to use this sample URL that's given in the earthquake catalog. And this query returns a list of earthquakes that occurred in a 24-hour period extending from January 1st, 2014 to January 2nd, 2014. So we'll go ahead and put that in here. And then we'll just use URL here. Okay, so now if you try to run this, it's going to say fetch is not defined. This is a Node project, so we're going to have to install a package called node fetch. So if you install that, you can bring it in here. Okay, and now we can use it. So let's go ahead and take a look at what the response looks like. Okay, it's a big response. As you can see right here, there's an array called features, and each object in the array looks like it's an earthquake event object. What we can do to reveal some more information is we can console log quakedata.features. All right. And then you see we get back more information, such as the magnitude of the earthquake, the location, the time, and also the event ID, which we may use later to search for individual quakes by their ID. Okay, but let's just focus on one single event for now. All right, so for our data in our application, all we really care about is the magnitude, the location, the time, and the ID. So let's see what we're going to do to get that data in this sort of customized shape that we want to put it into. Alright, so for example, I don't really want my time to be displayed like this, and I don't think you would either. So I've written a little bit of code to make things a little bit easier to understand. So here what I've done is I've just defined an individual quake this way. And from here I can get the date, and if I want to see what that date looks like, we know it should be January 1st, 2014, because that was part of the query. That's what it looks like there. We don't really want it to look like that. We want it to look a little bit cleaner and more readable. So what we can do is we can get the year. We can get the month. But if we get the month that way, it looks like this. Right. It looks like it's a 0. So it's basically the first index of an array of months, which has 12 elements in it. And in the first index would be index 0, corresponding to January. Excuse me. But we don't want that. We want it to actually say January, or at least I'm saying that that's what we'll want. So I've got some code here that handles that as well. I've defined a function. That function is called month name, right? And it takes in an index as a parameter. In this case would be index 0, and then it returns the value at that index. Right? So in this case, if it's month 0, it's going to return January. Right, so what I can do instead of this is I can say, I can make a call to my function month name and then pass in that index as a parameter. But now if I console log month, I should see January. And I do. So that's good. All right, and there's a little bit more that I've done already ahead of time. I wouldn't want to make you sit here and watch me go through all of it. Good. So also we get the day, or the date, the hour, the minutes, the seconds, and then I created this customized date string that will say that the earthquake occurred on, say, for example, January 1st, 2014 at 8 a.m. or 8:56 a.m. and 36 seconds. All right, and then we're also getting this timestamp, which is just this basic form it's already in, and we're going to use that when we implement cursor-based pagination later. Okay, so let's see what that date string looks like. Yeah. So, like I said, the earthquake occurred on January 2nd, 2014 at 8:51 and 36 seconds. Okay. Good. So, now that we know what our data looks like and that we can get it back in the way that we want it, for example, let's say, call it custom date, and we'll say that the magnitude is what? Up here. Quake.magnitude. Actually, quake.properties.magnitude. That's where we need quake.properties. And it's mag, actually. That's the way the response was. Let's just bring that response back so we can see it. Yeah, so it's properties.mag for that. And then the location was quake.properties.place. The time, and actually in this case what we want, I'm going to call it when, just to be cheeky. Alright, and that's going to be date string. And that's just going to be Quake.properties.time. Yep. All right. Also, one more thing we wanted was the ID, but that's not a property. It would just be Quake.id, if I remember correctly. Yeah, down here at the bottom we see the ID is outside of the properties. Okay, so if we print that out, should be custom data. Should be what we were hoping for. So let me go ahead and just comment this out so we don't see it again. Good. So here is our custom data object, right? This is what we want to use in our application. We've got the earthquake magnitude, we've got the location, right? We've got our customized date string for when it happened, we've got our timestamp for our cursor-based pagination, and we've got the earthquake ID so that maybe in the future we could make a query to the earthquake catalog by the actual Quake ID so we can just return that one event. Okay, so that's looking good. So going back to the Apollo docs, right, we look at this part that talks about hooking up our data sources. Right, first what we need to do is we need to make sure that we have this package called Apollo DataSource REST, or Apollo-DataSource-REST, because that's going to help us create our external API data source. So let's install that now. Is that what it was? Apollo DataSource REST. Good. Okay, we've got that in there. Just make sure. There it is. Okay, and now we're asked to create a file called, and we're not going to use launch, we're going to use Quake because we're not dealing with SpaceX launches but earthquakes. But first we need to create a folder called data sources. So go into your server folder and create a folder called data sources. And then in there create that file and we'll call it quake.js. This is going to be our Quake API. Right, and they give us some basic code for it. We can just copy and paste that in. Right, so this is not a launch API, it's a Quake API. Right, now you see here they've got a base URL, right, and they're dealing with SpaceX. We're dealing with the earthquake catalog, the USGS, and the base URL is right here. Right. Everything after this will be the query or other information. We'll attach to our requests. So let's put this in for our base URL. Now this package actually is nice because it's probably got fetch or Axios or something built into it that makes these API calls for us. But we don't just want to make a call to the base URL. We want that extended query. So you can see when we go down here, we need a method that will get a list of quakes between two dates. So we'll use this. And we're not going to call it get all launches, we're going to call it get all quakes. Okay, now first let me make sure everything's changed accordingly. Now I could easily just go up here and call this launches quakes, but that wouldn't do anything for us. What this is the query part of the request string that we're going to send. So we're going to tack that onto the end of this base URL. You can see here they say this.get.launches makes a GET request to, and then here's your base URL for their SpaceX, and then it adds on that query, right? It's querying all the launches. But for us, ours is a bit longer. It's a little more complicated. Ours looks like this. Can't believe I just did that. So we can call that our query. And then here, we can just add it. Good. And that's going to tack that on to the end of this base URL. And this is something that's just built into this REST data source from the Apollo DataSource REST package. All right, so we have that. And now what we're saying is we're going to check the response to see if it's an array. Right? That's what this array.isArray method is. If you go to the MDN web docs, you can see it says the array.isArray method determines whether the passed value is an array. But you remember in our Quake fetch here, when we looked at the basic response we got, right, it wasn't an array, it was an object. I mean, an array is an object, but it wasn't strictly an array. So our array starts here. So what we'll want to do is say array.isArray response.features. And then what we'll do is, since we're going to get back an array now, this is basically a Boolean response. If it's true, then what it's going to do is it's going to map over that response for each individual Quake object, and then process it according to this Quake reducer, which we haven't defined yet. Okay, but we shouldn't have response.map. We should have response.features.map. Good. So now we're ready to define our Quake reducer. And remember, if this response is false, then what it would return back is this empty array. But we already know it's not going to return a false response. All right, so now if you go back to the Apollo docs, you see that they have a Quake reducer method for you. Of course, they call it launch reducer. So we can paste that in there and change it accordingly. This will be Quake, and this will be Quake. All right, and this Quake is just the one that gets passed in right up here. Good. All right, and the ID we already know is going to be Quake ID. This cursor, like I said, it's going to be what we use for cursor-based pagination later. And if we go to Quake fetch, that's going to be this timestamp here, right, which is quake.properties.time. So we can just put that here, and then we're going to turn it into a string because we're going to require a cursor as a string type. Good. So we don't need the site, right? We're not dealing with that. What we do need is the, for example, location, right? And we'll need information on when it happened, right? So actually what we can do is we can go over here. We've already defined everything. Let's just grab all of this. And we don't want to return that. put it in up here. And so it looks like we've got a little bit too much stuff in here we don't need. We don't need this. Okay, so now what we want to return, first we'll want to return the magnitude. Actually, we can just borrow all this right here. So let's do that. Okay, so that should be good. That should return our data in the way that we want it. So if we go back to the Apollo docs page, there's a little bit more that they get you to do, like for example, write in a function that just gets individual launches, or in our case what would be individual Quakes. But we don't have to mess with that right now. We'll come back to that later. They also talk about hooking up a user API, which we're going to do in the next part. We're not going to do today. All right, and then it tells you to add your data sources to the Apollo server, and that's what we're going to do right now. Now, since we're not adding the user API today, we don't need to worry about this, but we do need to add in our Quake API. So go ahead and grab that. And we're going to put it in our index.js file. Right, of course, this is not launch API. It's Quake API. And the file name is quake.js. Okay, so we have that. All right, now we're going to add these data sources into our server, pass them into our server. Of course, we don't have the user API defined yet, so we'll get rid of that. Again, change everything to Quake API. Okay. And that should be it. All right, then we have to write a resolver or two. Actually, we're just going to write one today. And that's going to allow us to see our data in the GraphQL Playground. All right, so they go through what a resolver is. We already went through type defs in the first part of this tutorial. Now this is the other really important part that you deal with on the back end with GraphQL, and these are resolvers. So a resolver basically is described right here. It says that a resolver function accepts 4 arguments, right? Parent, args, context, and info. All right, so the parent is an object that contains the result returned from the resolver on the parent type. Args are it's an object that contains all the arguments that you want to pass into the field. Now context is important, right? Because basically for every request made, it says right here, all resolvers share the context object, and for every request, you can say, for example, find out if the user is logged in or not. Right? That information is stored in context, so you can use it for authentication. And it says here info. It's information about the execution state of the operation, which should only be used in advanced cases, which lets us off the hook, right? Because we're not going to be dealing with advanced cases today. All right, so we just need to hook up our resolvers in the Apollo server, and we can actually just paste this in as it is. We don't need to change anything. All right, we'll also need to add the resolvers here, pass them in as an argument. Okay, we've done that here. Okay, so now we just need to write the resolvers. Okay, so first we need a file called resolvers.js, and we'll put that in the server folder. Okay, and then we'll copy this bit of code right here. Sorry. Alright, so again, we're not dealing with launches, we're dealing with Quakes. Right, we're not using anything called a launch API, but a Quake API. And if you remember, the method that we defined in our Quake API was called getAllQuakes. Right, that's right here. Right. Also, we could, or we will at some point, be able to query a Quake by its ID. We would call it something like getQuake by ID. Right, we would give it a property of Quake ID. All right, and then finally, if we wanted to query for the current user, we could, but let's just comment that out for now. All right, and that should be good. All right, so we should be able to now run our queries in the playground and see that we get back the data we would expect from the Earthquake Catalog API. Okay, so let's actually run our server. Okay, and let's take a look at the GraphQL Playground. Alright, so here's our playground. Now if we want to check out our first query in our resolvers file, right, that would be the Quakes query. Right, what we can do is we can just type in Q, and already it brings up a list of your types that you can get. Right. Actually, it doesn't bring up a list, I'm sorry. It brings up the query type. So if I type in query, if I just type in control space, then it brings up all the different types. But for now, we're going to use just query. Open up a set of curly braces. Now, what's available to us here can be shown just by hitting control space. Right. So we see the Quakes query is right there, so we'll choose that. Now, if we just try to run it, it's not going to give us anything. Right? It says field Quakes of type Quake must have a selection of subfields, right? Which means we have to consider the properties that we have given to our each Quake in our Quakes list. So we'll have to reveal those as well. Again, if you hit control space, you see those properties come up. You've got ID. One more time, you've got location. Do that again. You've got magnitude. Do that again. You've got the time and date, and then finally you've got that timestamp that we created. Okay, now if we run it, we get the list of Quakes, right? And the data is in exactly the form that we wanted it to be, right? For each Quake, we get the location, we get the magnitude, we get when it happened, and we get this information displayed as we wanted it to when we created our custom date string. And we also get our timestamp here. Right, so that's nice. We're getting back exactly what we want. And you can see that this has all the Quakes that were returned in that response from the Earthquake catalog made up by the USGS, or at the USGS website. So great. We were able to see our query work, and we're able to see it in action. So later on, when we build our client side, we can see the shape of our queries and how they're going to be returned. And we can actually just cut and paste these this query code right here into our files, as you'll see. So for now, I hope that you feel somewhat comfortable with hooking up data sources to your Apollo server. I know that there was a lot in this video, and it seems like there's still a lot of magic happening. But if you take your time and you go through it and you think about what's going on and what exactly you're doing, you'll see that it makes sense. So next time we'll work on building a user API, and we'll end up just like today, finally querying that list of users, for example, that we haven't even created yet, and seeing that from the GraphQL Playground we actually have access to that data as well. So thank you as always for joining me, and I'll see you next time. Cheers.